Good morning, guys. Today we're going to be looking at reflections and non-rigid transformations, and we're going to explain, what types of reflections can happen, specifically with absolute value. So let's jump right in. Right. Today we're going to continue our exploration of transformations. So remember last class we talked about translations, and we talked about translating to the left and the right, and then translating up and down. So now we're going to focus on reflections, and later on in the notes we're going to look at non-rigid transformations. Non-rigid, and I'll explain it more later, is when you're changing the size of the shape. You're making it wider or narrower. But here we're going to be looking at rigid transformations where it keeps the same size. We're just going to reflect it kind of like a mirror. Okay, and so there's two types of reflections we can see. You can reflect something over the x-axis, and you can reflect something over the y-axis. And we've seen both of these in the parent functions. Where we're reflecting, there's some sort of reflection either on the y-axis or x-axis. And then when we're looking at it in an equation form, if we're reflecting over the x-axis, then we have a negative in front. We have a negative in front. So we're going to say, if there's a reflection over the x-axis, then the negative is outside. If we have a reflection, let me pick a different color. Just change the color here so we know that there's a difference. If we have a reflection over the y-axis, then the negative is going to be located inside. Okay, so let's slide over. I'm going to slide over to this example here, and we're going to see what happens to the points. Okay, so a couple of points that I can choose. Looking at the graph, is kind of picking out some points here. I can pick these 5 points. So those are the points. Negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. Okay. And the next thing is looking at the one underneath. Zoom out here a little bit. Okay. Looking at the one underneath. Oh, let me zoom out a little bit more just so it fits in the page. Okay. So we have reflection over, and then we have to decide which axis, right? So the question is the negative inside or outside of the absolute value? It's outside. So if we slide over, which one says outside? Outside, that means that the reflection is going to be over the x-axis. Over the x-axis. Okay. So I'm going to put it, I'm going to color it in red. So I'm going to say, it's over the x-axis. I'm going to put x. And if I do that, so let's say I put like my reflection line, my mirror. Yeah. If this blue line, the x-axis is going to be my reflection. then the graph, let me pick red, is going to do the following. Okay. So notice, right? If we compare the parent function, again, this is the parent. If I compare them, these are opening, it's like a V opening upwards, but the moment I have a negative in front, there's a reflection of the x-axis, so it points them downwards. And so what are these 5 points? What are the locations of these 5 points? They are, let's see this point, it's going to be -2, -2, -2, -2, right? If I plug in -2 in here, it's going to give me a +2, which becomes a -2. So the points are -2, -2. This point right here is -1, -1. The next point that's at the center of the x and y axis is 0, 0. And then I have 1, -1. And 2, 2, -2. Okay, so that's the reflection over the x-axis. Then we're going to go down here and look at the reflection over the y-axis now. So this, when the y-axis, when the negative is inside, there's a reflection over the y-axis. Now, remember, the parent function looks like this. Right, this purple is the parent function. But now, if we're going to reflect over the y-axis, then let's say this is my reflection line. Let me change this to green. Okay. And let me change this to blue. All right. So I just want to make sure reflection, 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 reflection. Right. So this is the y-axis, the reflection. But if I reflect this parent function, if I reflect it over the y-axis, does it really create a reflection? You know, or is it already reflected? Are the points going to move? For example, if I take this point here and I reflect it over the y-axis, you know, it's 1, 2, it's 2 steps away from the y-axis. Isn't the reflection going to be 1, 2 steps away? So what ends up happening is when you reflect the absolute value, parent function over the y-axis, you get the same thing. It doesn't change the graph. So I'm going to color it blue. Okay. So this is the reflection. This is the reflection over the y-axis is the same as the original parent function. So the points for the reflection, you know, if I zoom out so we can see the whole picture. This is the parent function up here on the top. And so if I reflect over the y-axis, if the y-axis is my reflection here, if I'm reflecting across the y-axis, I get the same graph. So the points are going to be the same. I'm going to copy the purple points. Copy the purple points. Okay, so that's one thing to know. For the absolute value, the parent function and the reflection over the y-axis are the same. Okay. The next thing is, let me zoom back in here, the non-rigid transformations. And so we have, it says, if we're looking at non-rigid transformations, they change the shape of the graph of the function by either expanding or compressing. So, changing the shape by making it like spread out or come back in, narrowed in. This is non-rigid transformations, can be horizontal or vertical. So we're going to jump over to the next page and talk about non-rigid transformations. So there's vertical and horizontal compressions, and they look different for each one. So we're going to go through each one, and we're going to see, what's the difference between each one and what's happening in the different compressions. But the idea here is where there's a number outside, in this case, if you compare these function notations, we see that we have a blue A and a red A, and they're both outside of the function. They're in front of the function. And then we have a blue B and a red B, and they're inside of the function. So that's one main difference. So like kind of like when we talked about translations, if the number's inside, it's a horizontal. If it's outside, it's vertical, right? Now, what's the difference between the blue and the red? It says that the blue has to be greater than 1. If it's greater than 1, so if the number in here is greater than 1, like 2, 3, 4, there's vertical expansion happening. If the number in front of the function is between 0 and 1, so what's a number that's between 0 and 1? That's like your fractions, like 1/2, 1/4, 3/4, 1/8. These are vertical compressions. And kind of similarly for the horizontal, if B is greater than 1, we have a horizontal compression, and if B is between 0 and 1, we have an expansion. So we're going to break these down and kind of look at them each in their own perspective. And so again, we have the parent function. The parent function has its own points. Again, it's -2, 2, which is this point right here that I'm putting on the graph. Then we have -1, 1, which is this point right here. 0, 0, this point right here. 1, 1, this point right here. And 2, 2. We're going to look at what's happening in both cases. So I'm going to zoom out slightly, just enough to fit the key points. Okay, so what's happening here is you're multiplying the values times 2. So here, I'm going to actually plug in some values. Okay, so I'm going to ask you to do some calculations with me, some straight multiplication by 2. Can we multiply by 2? Yeah. So let's take the x values from the parent function. So let's take the first x value, that's -2, right? So I'm going to take it over here and put it into this function. So what happens when I take an input? If I put -2 as my input, let's write it out a little bit. So 2, absolute value of -2. What's the absolute value of -2? +2. What's positive 2 times positive 2? 4. Okay. Let's try out another input. Let's try out negative 1. What's the absolute value of negative 1? Positive 1. What's positive 1 times 2? 2. Okay, let's plug in 0. Absolute value of 0 is 0. 0 times 2 is 0. Okay. Now let's plug in. Let me just erase this, but let's just plug in. So what's 1? If I plug in 1, what's my output? So what's 1? Absolute value of 1 is 1. 1 times 2 is 2. Absolute value, let's go to the last point. If my input is 2, 2 times 2 is 4. Okay, so if we plot these points, for example, let's plot negative 2, 4. That's going to be negative 2, positive 4 up here. Negative 1, positive 2. 0, 0. 1, 2. 1, comma 2. And 2, 4. 2 to the right, 4 up. Right, so these are my 5 red points. If I connect them, it'll look something like that on the right side, and then on the left. Okay. All right, so we have the parent functions over here. So we have like the original graph, what it should look like. And then what we're doing is basically, we're trying to see what's going to happen if I put a number in front of the absolute value. In this case, what if I put a 2 in front and I plug in some values and I get some points and I plot these points, which are the ones we plotted? Does the graph look different? It does, right? It looks like there's some sort of maybe expansion you could think of. So it's kind of like if you take, these arrows and you kind of stretch them up vertically. So it's kind of like these arrows are moving up in this direction, causing it to stretch out in the vertical direction. Okay, so this is called a vertical expansion. Vertical expansion. Okay, so let's go to the next one. We're going to do this plugging in game again. We're going to use the same x values as before. So let's start with negative 2. If I plug in negative 2, the absolute value of a negative 2 is positive 2. Positive 2 times 1/2 is 1. Then the next value we're going to plug in is negative 1. The absolute value of negative 1 is positive 1. What's positive 1 times 1/2? That's 1/2, or we could say 0.5. Then what if I plug in 0? 0 times 1/2, or 0 times anything, is 0. Then if I plug in 1, what's 1 times 1/2? It's 0.5. And then the last one, 2. What's 2 times 1/2? That's going to be 2 over 2. 2 divided by 2 is 1. So let's plot these points and see what we get. So we get negative 2, 1, and then negative 1.5, 0, 0, 1.5, and then 2, 1. Like this. Okay. So again, let's go back and compare. Let me just zoom out a little bit. You can see both diagrams. So I see the original is over here on the left. Here we have what happens when we multiply the absolute value by something in front. Since this value is 1/2, it's between 0 and 1, it causes a compression, vertical compression. Okay, so it kind of pushes these arrows down vertically. You know, it pushes them closer to the x-axis. Okay, let's look at 2 more transformations. And let me see where I can zoom into. Let's zoom in here. Okay, that looks good. Okay, so now I'm changing colors here. We're going to plug in. We're going to plug in the same values again. So it's going to be, you know, negative 2. What's going to happen when I plug in negative 2 here? It's 2 times negative 2 is negative 4. The absolute value of a negative 4 is a positive 4. Then I'm going to plug in negative 1. 2 times negative 1 is negative 2. The absolute value of negative 2 is positive 2. 2 times 0 is 0. Plug in 1. 1 times 2 is 2. Plug in 2. 2 times 2 is 4. So that gives me negative 2, 4. Negative 1, 2. 0, 0, 1, 2, and 2, 4. So here we have the 2 is inside, and so it creates a, you know, horizontal compression. Horizontal compression. So it's pushing the arrows, you know, closer to the y-axis. Over here, we had vertical compression. So I'm just going to put arrows to show us where it's going. So in the one before, we had vertical compression where it's being pushed, you know, downwards towards the x-axis. Okay. Oh, sorry. Let me put the name here. This is vertical compression. Then we have horizontal compression. And the last one here is, I believe, horizontal expansion. So we're going to do, you know, negative 2. What's negative 2 times 1/2? It's negative 1. The absolute value of negative 1 is 1. Let's try negative 1 as our input. Negative 1 times 1/2 is negative 1/2. Negative 1/2, the absolute value of a negative 1/2 is positive, so I'm going to put positive 0.5. Then I'm going to plug in 0. 0 times 1/2 is 0. to plug in 1. 1 times 1/2 is 1/2. The absolute value of 1/2 is 1/2, so that's 0.5. And then 2 times 1/2 is 2/2, which is 1. The absolute value of 1 is 1. So if I plot these points, it's -2, 1, which is right there on the grid. The -1 and 0.5 up, 0, 0, 1.5, 2, 1. So you see something like this. And this is causing the arrows to kind of move, stretch out that way. And so this is called horizontal expansion. You're expanding something. Okay. Now we're going to jump to the next page and look at some examples, some graphical examples. So we're going to graph the absolute value functions, fill in the table with and then fill in the table with the attributes. So kind of like what we did last class with translations. And so there's a combination here. There could be what we learned today, we saw in the examples today, in combination with the last class. Okay, so we have, let me see how I'm going to break down the color coding here. Okay, so this is what I usually do. I do expansion and compressions. I do the inside, like here, I do it in red. So there's a -3 being multiplied inside. So anything that's happening inside is going to be horizontal. And there's also a negative, so there's a reflection. But there's a horizontal, if it's greater than 3, it's going to create a horizontal compression. And there's also a reflection over the y-axis. And then there is -2. So that's creating a vertical translation down. Okay, so what we can do also is plug in some points. So if I plug it in, so let's do the same thing we were doing before, right? -2. So if I plug in -2, I'm going to do the absolute value of -3 times -2. Close absolute values -2. Right, and so I'm just copying. We have over here -3 times -2 -2. -3 times -2 -2. So -3 times -2 is +6. Absolute value is 6. 6 minus 2, 4. Then let's plug in -1. So if I plug in -1 here, negative times a negative is positive, so +3. 3 minus 2, 1. If I plug in 0, negative 3 times 0 is 0. 0 minus 2. So if I plug in 0, 0 minus 2 is negative 2. If I plug in 1, if I plug in 1, negative 3 times 1 is negative 3. Negative 3, absolute value of negative 3 is positive 3. 3 minus 2 is 1. And then the last one, 2. Negative 3 times 2 is negative 6. But becomes positive because it's an absolute value. 6 minus 2 is 4. So I'm just going to do the points just for one example, and I'm just going to shift over to translations. So let's plot these points. What color do I want to do them? Let's do them in blue. Okay. So negative 2, 4. Negative 2. Oh. Negative 2, 4 is yes, okay, negative 2, 4 is right there. Negative 1, 1. Zero, negative 2. One, 1. And 2, 4. And then we're going to write what type of I should say transformations. What type of transformations are going on here? So there is a horizontal compression by a factor of 3. There's reflection over the y-axis, and there's one more. There's a vertical translation 2 units down. Okay, so I'm just breaking down what's happening. There's a horizontal compression because it's happening. There's a 3 being multiplied inside, so that's a horizontal compression by a factor of 3 because it's 3. If it would have been a negative 4, I would have said 4. If it's 5, I said 5. Then because of the negative, we say that negatives cause reflections, so they're reflecting over the y-axis because it's inside. And then there's a vertical translation 2 units down. And so the next question would be, what's the vertex? So the vertex is right there. What's the location? It's at 0, 2. Zero, negative 2. Are there any x-intercepts? Yeah, there's an x-intercept here and here. So I'm going to say that that looks like negative 0.50 and 0.50. So it's negative 0.50 and 0.50. And the y-intercept is the same as the vertex, so it's going to be at 0, negative 2. We have a minimum at 0, negative 2. Domain, the arrows are going to the left towards negative and positive infinity. And the range, what's the lowest point? The lowest y value is at negative 2, and the highest is positive infinity. So it's bracket negative 2 to positive infinity. Okay. Let's go to example 2. This one you got to keep an eye out for because there is a negative, and you might miss it. So this negative I pointed out in red is right there, and then there's a plus 3. It's happening inside. So what I marked off in red is happening outside, and it's reflecting over the x-axis because it's outside. And then the plus 3 is a horizontal translation to the left. Because remember, we got to think oppositely for the horizontal translations. Right? If you say plus, we go in the opposite direction. And I'm not going to focus on the points. I want to see how we can take the parent function and translate it. So I'm going to write the transformations over here. There's a reflection over the x-axis, and there's a horizontal translation 3 units left. Okay. And I'm just color coding the transformations so that when we graph it over here, it makes more sense. So what I like to do is I like to put the parent function points. These are the original points of the absolute value, because we're focusing on the absolute value right now. Okay, and I want to know how are these points going to move. So let's go in order. So first in red we see reflect over the x-axis. So how is that going to look? You know, if I'm reflecting over the x-axis, basically if the x-axis is my reflection line, then these points are just going to be a reflection like this. Right? Do you guys see that? So these purple points, the original ones, are going to be reflected downwards. Okay. What's the other transformation that's happening? All the points are moving to the left 3 units. So it's 1, 2, 3. Right? 1, 2, 3. And that's going to be my point right there. I'm going to do 1, 2, 3. It's going to be my other point right there. And then I'm going to get another point here, and then here, and then here. So my final graph's going to look like this. Okay, so notice again, the parent function is this purple. This is the original parent function. What's happening to it? It's being flipped. Instead of opening upwards, it's opening downwards because the negative, there's a reflection. Then after it's opening downwards, it's going to shift to the left 3 units. So it's going to go 1, 2, 3 and create a V there. Okay. So again, I'm just using the parent function as my template. Okay. And now that I have everything, I'm just going to keep the blue graph and kind of talk about the characteristics of it. So first one is, what is the vertex? It's right there. It's at -3, 0. Does it have an x-intercept? Yes, at -3, 0. Does it have a y-intercept? Yes. Let me pick a different color for that y-intercept. Right there, it's at 0, -3. Do we have a minimum or a maximum? Well, now, because the arrows are pointing downwards, we have a highest point. So we have a maximum now, and the maximum is located at the vertex. Domain, from left to right, it's going to -infinity to +infinity. And then range, from bottom to top. So as I'm looking at the bottom, the arrows are going to keep going down towards -infinity. But what's the highest y value that we're going to get to is 0, with a bracket because it's closed. Okay. Then we're going to look at, is it in this page? No, it's in the other page. So I'm going to shift over to the last page. And there's one more graphing, and then there's equation. Okay, so here, again, we're going to break down the transformations. So I see that there's a 1/2 outside being multiplied, right? There's a -1 inside. There's a +4 outside. So we have a vertical compression by 1/2. Then we have a horizontal translation of 1 unit to the right, and then there's a vertical translation for up. So yes, so that being the case, oh, sorry, I should have written this down here. That's why there's more space. But it's fine. Okay, so what I wrote up here should go in this space. Right. Since there's a lot of colors happening here, I'm going to put the parent function in using black points. Right. So these are the parent function points. but I'm going to move them, and I'm going to, work on the compression here. So for the compression, it's going to cut the distance in half. So if I see, for example, this vertical distance, the 1/2 is going to cut that vertical distance in half. So if it's 2 steps away, half of 2 is, half of 2 is 1. So that's going to be the new vertical location. And then here, what's the vertical distance here from the x-axis to this point? It's a vertical distance of 1. What's half of 1? What's half of $1? 50 cents. So it's right there. Half of 0 is 0. Half of $1 is 50 cents. Half of $2 is $1. So this vertical compression is like squishing the points down. And then we're going to translate the points 1 unit to the right. 1 unit to the right and 4 up. 1, 2, 3, 4. So right there. And do that again for the next point. 1 unit to the right and 4 units. So 1, 2, 3, 4. Pretty much we're going to have this shape. So the same shape that the red is making, it's going to do something like this. Okay. So again, the black points are like the parent function. Then the reds are what happens after the graph has been compressed. And then the green says we're moving to the right one, and the purple says we're moving 4 up. And so you can go back in the video, but I'm going to erase all this just to keep focus on the blue and answer some questions about the blue graph, right? So the questions are, what's the vertex? That's this point right here that's located at 1, 4. 1, 4. Why does that sound familiar? It's the translations. It's the transformations, sorry. It's 1, 4. It's 1, 4. Is the graph intersecting the x-axis? No, so I like to put none. Is the graph intersecting the y-axis? Yeah, it looks like at 4.5. So I'm going to put, I like that point, and it looks like it's at a location of 0, 4.5. Next question, do we have a minimum or maximum? Looks like we have a minimum at the location of the vertex. The domain is going from left to right, so left negative infinity, right positive infinity. And the range, what's the lowest that the graph goes? It's 4 to a maximum of infinity. So bracket 4 to infinity. All right. Next, kind of like what we did in the other notes, we're going to break down the equation of these problems. So we're using the same parent function of the absolute value. absolute value, absolute value. Then we have reflection over the y-axis. So when we reflect on the y-axis, it's going to cause us to write, a negative. And over the y-axis means the negative is going to be outside. Then we're going to do translating 5 units up. So that's plus 5. Outside. So the function notation is going to be f of x equals a negative outside of the absolute values. The x is inside. Then close the absolute value. And then do plus 5 outside. Okay. The next one is horizontal compression by a factor of 4. So horizontal compression means, multiply by 4. Then translate down 9 units. So minus 9 outside. Oh, and this is multiplied by 4 inside. Inside. Horizontal happens inside. So it's going to be, the equation is going to be f of x equals the absolute value. Let me erase this. The absolute value of x, but we're going to multiply by 4 inside. So I'm going to put a red 4. I'm sorry if it takes a while. It takes a while for the colors to load sometimes. And so closing it, right? Closing it because the minus 9 is going to be outside. Right, and because what I've highlighted in purple, that's a vertical translation. So I'm going to put VT up here and VT down here. So any vertical translations, happen outside. And if it says up, then you're putting plus. If it says down, you're putting minus, right? And then there's, shift over to example 6. We're doing absolute value again. We're doing reflection over the y-axis. So that's negative. Outside. With a vertical compression by a factor of 1/4. So multiply by 1/4. And then translate 7 units to the right. So that's in green, it's a horizontal translation of minus 7. And then 1 unit down, that's a vertical translation, minus 1. So my equation is going to be f of x equals, there's a negative outside and multiplication of 1/4 outside because it's a vertical. So it's going to be negative 1/4 absolute value of x. Oh, horizontal happens inside. Vertical translations happen outside. And so inside it's going to be minus 7. Close the absolute value, and then minus 1. Minus 1. All right. So that concludes example 6. Then we're going to look at 2 more examples, and these are kind of combining the graphing and the equation aspect. So it says write the equation of the absolute value function that describes the graph below. So if I give you a graph, can you give me the equation of that line? And so remember, the parent function, let me do the parent function in purple. Is this line. And do the parent function over here too. Over here. And so we want to see, what's changing, how is it moving? So are the arrows still pointing the same way? So we have f of x equals and actually let me zoom in a little bit just so the font is bigger. Okay, so we have f of x equals, it just looks like we're moving the absolute value function to the left. 1, 2, 3. So to the left 3. And how many down? Use a different color just to, I'm going to change things up a little bit just because I already have purple there. So it's 1, 2, 3, 4. Down 4. It's going to be something like the absolute value of x plus 3, close the absolute value, then minus 4. Okay, so we're going to the left 3, down 4. And then see what's happening over here. Right, we notice that it's just moving 2 units to the right. 1, 2. So to the right. 2. And it looks like it's reflecting over the x-axis, right? If I put a reflection line here, looks like it's reflecting on the x-axis. So that means the equation is going to be f of x equals negative absolute value of x minus 2 close absolute value. that's it. So now we completed the notes. And so next class we'll see if you guys have any questions, and then we'll try and answer them, and then we'll work from there. Thank you for joining me today. Have a great day, guys.